Well, another view of standard position angles brings us into something called radian measure. Radians, some people have a little bit harder time using this, but it's a different way of finding the amount of rotation. We're used to dealing with degrees, not so much radians, but radians are very, very similar in their way. We say, for example, one full rotation, instead of being 360 degrees, is 2 pi radians. A good way to think about that, if you remember your formula for the circumference of a circle, right? The circumference of a circle is equal to 2 times pi times the radius. So if you imagine a circle with a radius of 1, you can see that that circumference, 2 pi times 1, would be the amount of radians as well. So it has to deal with the circumference of the circle in a way. And we can divide that up. If we go 1/2 of a full rotation, right, 1/2 of 2 pi is pi radians. That puts us there instead of 180 degrees. Pi over 2 radians was half of that. So pi over 2, that defines our acute angle, right? If we have an angle in radians, then in radians we would say that if our angle is between the measures of 0 radians and pi over 2 radians, then we've got an acute angle. And if we've got an obtuse angle, it's greater than pi over 2, but less than pi radians. Right? A right angle, of course, will be a pi over 2 angle. And a straight angle will be an angle of pi radians. Now you'll notice that I'm not actually writing radians or rad or anything after that. I'm just actually writing the angle itself. You won't see a symbol. So it is very important to discriminate between radians as angles and degrees as angles, in that if you have a radian, you don't put like a little degree mark, but if we had a degree mark, we would mean 180 degrees. Our equivalent angle to pi radians is 180 degrees, and I put the degree mark after the degree to make sure I know the difference. Okay, so this is important to us. So let's talk about this. Positive, negative angles, of course, it works the same way. If we rotate in the clockwise direction, a counterclockwise rotation, we get a positive angle. If we go in the counterclockwise direction, so if we rotate to the clockwise, we get a negative angle, negative rotation. Okay, negative rotation. So what would we do right here? Well, there's a couple of ways of putting this. First of all, you might have to recognize that pi over 2 forms our right angle to kind of get a picture of where some of these angles are. An angle like pi over 3 is acute. It's an acute angle, right? And so we can get an idea of where some of these angles lie. All right, so let's say that we're told to find coterminal angles. Well, when we were dealing with it in degrees, we had to add or subtract 360 degrees in order to get that rotation. Well, in this case, we're not going to be adding or subtracting 360 degrees. We're going to add or subtract 2 pi instead. Okay, so add or subtract 2 pi to an angle to get its coterminal position. So let's try 7 pi over 6. 7 pi over 6 is an angle, and I'll draw it over here in my standard positions. 7 pi over 6 is an angle. Well, here is pi. Pi is equal to 6 pi over 6. So if I wanted to get a visualization of where 7 pi over 6 was, I'm going to go pi over 6 more. So 7 pi over 6 is pi over 6 greater than pi. Right, so here's the angle 7 pi over 6. Now I want to find a positive coterminal angle. If I wanted to find a positive coterminal angle, I'm going to take my angle 7 pi over 6, and I'm going to add 2 pi. Now, for reference, because it is pi over 6, we would have to get a common denominator to add these two. So I'm going to be taking 7 pi over 6, and I would add 12 pi over 6. 12 pi over 6 in order to get that, and that's going to give me 19 pi over 6 is my coterminal positive angle. So 19 pi over 6 means as if I were to take my standard position angle, rotate to the 7 pi over 6 position, and then rotate around 2 pi radians more to get me to the angle 19 pi over 6. There it is, 19 pi over 6. If I wanted to get a negative angle, I'm going to subtract 2 pi. All right, so 7 pi over 6 minus 2 pi. Let me extend this out a little bit. 7 pi over 6. If I want to get a negative coterminal angle, I'm going to subtract 2 pi. So, like we did above, we're going to take 7 pi over 6. We're going to subtract 12 pi over 6. And that's going to give us our angle of negative 5 pi over 6. And in terms of rotation right here, negative 5 pi over 6 would be here. Negative 5 pi over 6 in standard position. Again, it's coterminal because it terminates in the same position. Let's do the same thing for 4 pi over 3 that we just did. Let's talk about getting an angle. Let's get a positive coterminal, right? Positive coterminal, we're going to take negative 4 pi over 3. And we're going to add 2 pi to do this. Now, you don't have to draw the angle in order to get this picture going. We could say, well, negative 4 pi over 3, we have to add these fractions together, would be added to 6 pi over 3. And so our positive coterminal angle is going to be positive 2 pi over 3. And again, let's go for our negative coterminal angle. So we're going to take negative 4 pi over 3. We're going to subtract 2 pi this time. So subtracting 2 pi is our negative 4 pi over 3 minus 10 pi over 3. And that gives me an angle of negative 6 pi over 3. I'm getting ahead of myself. See, this is what I get when I get excited around all these angles like this. Here, let's try it again. This is 6 pi over 3 that I'm adding. So I'm getting negative 10 pi over 3. Sounds better. There it is. That would be my angle.